US Physics Olympiad, year 2011, F equal MA, first round. Problem number 21. Solution for this problem you can find below this video on the reference in the description. An engineer is given a fixed volume Vm of metal with which to construct a spherical pressure vessel. Interestingly, assuming the vessel has thin walls and is always pressured to near its bursting point, the amount of gas the vessel can contain, N, measured in moles, does not depend on the radius r of the vessel. Instead, it depends only on volume, measured in cubic meters, the temperature, T, measured in kelvins, the ideal gas constant, R, measured in joules per Kelvin moles, and the tensile strength of the metal, sigma, measured in Newton per square meters, same as pressure. Which of the following gives N in terms of these parameters? Of course, we cannot solve this problem directly, but for this data we can use dimensional analysis for this reason, because we have 5 answers and we can choose correct one using just dimensional analysis. So solution will look like this. So number of moles N must be proportional to this expression, where all these alpha, beta, gamma and delta power coefficients we have to solve. For that we need to express dimensions for each particular parameter. Let's do this. So volume we measure in cubic meters. Temperature we measure in kelvins. Ideal gas constant we measure in these units, which finally has this dimension. And the sigma, which is tensile strength, we measure in these units, and finally that's this one. Now let's put all this expression to our proportion. When we put all these expressions to this proportion, we have this proportion. And now we just need to equalize all coefficients for all independent units. So from this proportion we have 5 different equations from which we can find all coefficients. So for gamma we have -1, for delta we have -1, for beta we have 1 from here and from here, and for alpha we have 1. And finally we have this proportion, that number of moles proportional to this expression, which is answer A. Problem number 22. Solution for this problem you can find below this video on the reference, the description. This graph depicts the torque output of a hypothetical gasoline engine as a function of a rotation frequency. The engine is incapable of running outside of the graphed range. At what engine RPM, revolutions per minute, does the engine produce maximum power? Solution. From rotational dynamic we know that power equal torque multiplied by angular velocity, and this is the formula. Now let's look at this graph. On axis X we have omega, and on axis Y we have torque. So we need to find the points where production of these two units have a maximum. Let's see, when we are going from point 1 to point 2, torque and omega increasing, and after point 2 we have omega increasing and torque decreasing, and in point 3 we have torque is increasing and initially omega is not decreasing. So it means that from point 2 when we are going to the right, and from point 3 when we are going to up, power is increasing, and somewhere between point 2 and point 3 we have a maximum for this point. So that's the solution. D is correct answer, in some point between 2 and 3.